Hey, it's Paul Seaver from Palm Beach Springs Water Company. This video is for those of you who are using plasma vortex destruction for PFAS chemicals in water. So what I have for you is a pre-treatment to optimize your system. Your system will run at its perfect performance if you can give it a pure acidic environment of around 3.0 pH. Now, you can get your pH down to 3.0 pH, but good luck getting a pure acidic environment. You don't have the equipment for that. I do. So what I'm going to do is I'm going to split. Freaking power flash. That threw me off there for a second. I don't know what it is. Every time this time of morning it does that. Okay, we're going to split H2O. And we're going to split the acidic from the basic and the ions. Okay? And so now all we're going to have is positively charged hydrogen ions on an acidic side with absolutely no basic influence whatsoever. So, I have a little demonstration that I do for agriculture. This isn't my first take on this video, so the one I already shook up. But the thing about glyphosate, Roundup, whatever you all are familiar with, is it doesn't want to be mixed in with anything that's basic. Now I use cinnamon and clove oil to demonstrate it because you can't see glyphosate in water. So, glyphosate has a pKa of 10.6. Cinnamon clove oil having the eugenol in it has a pKa of 10.3, so they're very similar. And they react very similar to basics in water. So if you have any basics in your water whatsoever, you're going to get something like this going on. Okay, plus it won't mix up. Well, it mixes up in this one because it's electrolyzed. But now, this is if you have a pure acidic environment. Now, usually this is clear until I mix it up. But like I said, I just mixed it up in the last video, which I did twice this morning. But the point is, see the oil. The oil's perfect. Okay? So it'll only stay stable like that in a perfectly acidic environment. This has been in here for 8 years. 8 years. It's sitting in the sunlight, which is why it's dark orange, on a windowsill to prove stability. Now, 6.45 Ionic Product, structure-free molecule separation. Okay, the same energy as what's in 200 degrees of heat, but we don't use heat, of course. So now you could take something like a organic oil, essential oil, and you can mix it up in the water because it's compatible, structure-free. So this obviously has way too much in it, so that's why you can see it on the bottom. But if it had the proper amount in there, it would just be clear. All right, so that just goes to show you the difference between when we separate the ions of water, and if you have perfect separation, see the oil's falling out, but there's no problem with it. It's brand new, clean oil. If you got all the water off the top of it, you would never know that this was in anything. So we showed you the difference between separating the basic from the acidic. So now I have my machine here that does it. So I have a batch tank right here. Okay, so it's just being fed by my well water, plus it, you see it has some sodium chloride in there from rinsing out chlorogamma. Let the TDS come up a little bit. So my well water is about 500 part per million. This is showing about 1100 parts per million. I tried to, it was higher before, but I put some extra water in there and diluted it down a little bit. The pH is showing 8.7, but this pH meter isn't really correct. So it could be 9.7 because it's usually 1 pH off lower. So, but as we're starting this, so you can notice the changes, correct or not, we're starting at 8.7. Alright, so I got my machine here. I already preset it, and hopefully I just turned it on and I don't have to do any more settings. So we just hit the start button, hit the run button, hit the start button, and we'll let it warm up. And then what I'm going to do is I set it to start out low, and then I'm going to start to bring the pH up to show you that it's not a one-shot wonder. It's not just, oh, it makes 3 pH water. No. You can, it's a tuner. You can make the pH anywhere from 11.8 to 2.5. Okay, so let it warm up a little bit, and I got a little with the red one because we're going to do both sides. I don't know if my ORP meter is going to work. I tried it on the last one and it didn't. It was working fine yesterday. I hate those things. Now all of a sudden this morning I want to make a video and the darn thing ain't working. Alright, we're going to take some high side and we'll rinse out the container. We'll pour that in there. And we'll put enough in there so we can reach our meter. I got it set pretty low on purpose because I want to get a really low number. So the lower the slower the flow, the lower you can go, and it's all relative to the chamber type. This chamber is only 4 liters a minute. All right. Then we're going to take the pH meter, because it takes a minute. And we were at 8.4 or whatever, right? Okay, so while that's doing that, I'm going to take the basic side, which we don't need. We would just send this back to the source for reprocessing. I won't get into that entire thing right now. But it's basic now. Put it back in, it comes out acidic next time. Its polarity will be flipped. So there is no wastewater. Everything eventually gets converted to acidic, although we're using makeup water, so it's going to be a constant process. All right, the pH meter is still balancing. I'm going to see if okay, good, we got ORPs. So let the ORPs balance to it. It's kind of sensitive. If you shake the thing, then it doesn't run. And I would say yes, we're definitely still running 1 pH low, because we should get down to somewhere around 2.7 to 2.5, 2.4. We're at 2.7 now if we're running, 1 low. So, and then to back it up, there's your ORPs. But we're at 1133 now. That'll vary a little bit, but we'll always be over 1100. So, that backs up that we're at about 2.5 pH. That's all. You gotta have a way to back it up, right? Well, there it is, right there. Now we're using the same meters. We're going to check the high side, and then after that we validate that this is all working and what the corrections are. After that, then what we'll do is we'll change the pH. We have to give it a second. So I was going to say something and I forgot what it was now. God, getting old sucks. Said I wasn't going to get into it. Oh well, I don't remember. Too early in the morning. I do know something else I want to do, though. I want to see if we created any gases strong enough. There's not a lot of electrolyte in there, so usually to create gases strong enough to measure with a strip, you got to have more electrolyte. Well, let's see. Let's see, just for... Oh, man! Oh! I never did this before with fresh water. I would say it's every bit of, it's over 100 parts per million, because it's over 50, but it's under 200. So it's probably somewhere around 100, 125 parts per million chlorine. Let's see the hydrogen peroxide. The pH is done, and it is. It's 11.8. Might even be a little higher. Now these ones are hydrogen peroxide. Now tell me we ain't giving you a boost to begin with. You're getting chlorine, hydrogen peroxide, ozone, hydroxyl radicals. Oh yeah. Let's see. A little bit. But usually it's about half the value of whatever the chlorine is anyway. So if we're only at 100 or something on chlorine, then the hydrogen peroxide should only be maybe around 50. And that's about what it is. So it's right on the money. See, we're yellow, we're not white, but we're certainly not orange. And there's no orange on there. So, you know, we're 50, 50 or under. But, so there's your gases from electrochemistry, and so these are stable. So these are dissolved gases, these aren't infused. So this is different than what the Vortex is creating. You're creating a bunch of gases and then shoving them down the Vortex. I do that outside too. And, but in here, what we're doing is we're dissolving them within the molecule of H2O for delivery. So now you've got complete 100% molecule separation with dissolved ROS gases that are every bit as strong as the ones you're making, if not stronger, because they're powered by 10,000 mA charged ion on the inside. So, and then you got your single molecule separation to utilize every single one of them. So now you've got infused gases from your Vortex with dissolved gases from my machine. How can you go wrong? How can you go wrong? There's no way in the world it can't take your system to its optimal performance. So you have what I call my finishing. I have a different program for finishing than you do, but it basically does the same thing. I just don't use plasma. I just use direct proton charge. But you got to be able to, even there, both of them have the same problem. Your system and my system have the same problem. Got to have the pre-treatment. So now where we're at is on this side. Now we are at 1.5 on one end. We're at 11.1 on the other. So we're really probably at 12.1, which would be about right with the way I have it set. And our ORPs, I just shook it up a little bit. It was negative 800 something. We're at negative 800, and I can't read backwards. I guess 808, 809, 811, 14. Usually it gets up to about 850, negative 850. So we're 1100 plus on the low side, negative 800 plus, or minus, on the high side. So same meters. And what did we have? 1.5 pH, 11.2. Obviously, neither one of these meters are calibrated, but they do prove what we're doing. That's all I use meters for. I don't have to build anything specific. So I just use the meters to make sure I'm getting what I'm supposed to get. Now, we don't care about the high side because we're just going to send it back like I said. And like I said, it's not wastewater because once it goes back into here, it gets converted to acidics. So there's no wastewater. Everything gets converted to acidics in the end. So now let's throw this out, okay? And let's take this and let's change the pH. Let's try to make the pH right at, no matter if the meter is right or wrong. It makes no difference in the world. What I'm going to do is I'm going to make 3.0 pH, and here's the reason why. So, Professor Gang over at FSU, who knows as much as God about this stuff, this is what he does for a living, landfill leachates and PFAS and stuff. So he told me what his opinion is, we want to be less than 5, but we don't want to go lower than 3. Okay, so a 3 is the maximum for optimization, which most people can't do. I'm going to do 3. So bear with me for a moment while I adjust my machine. I'll have to check it a couple of times. I don't know the exact setting. It changes with each water type. So with this, and what we're talking about, once my meter calibrates down to low pH, then it'll just pop from one to the other. From what we're talking about, we don't really care about ORPs or the chlorine gases or any of the other gases. What we want is pure acidic at 3.0 pH. That's my only objective for you. Everything else is a bonus to you. So we were at 1 point, what did we say? On the meter, we were at 1.5 on the low side, right? Oh, hang on, it's still calibrating. It's a boring job waiting for these slow meters. You could ask for a better environment for your Vortex. I understand what you need, and I'm just going to create it perfectly for you. Nobody else can do this. This is a one-of-a-kind machine anyway. This is an R&D machine. I custom ordered it. It can do some special stuff. The next R&D machine I ordered, now that I know all the different things that I stalled myself on with this one, my next one's really going to be fantastic. All right, right now it's slowing down. So right now we're at 2.5. It's still dropping a little bit, so I know I gotta adjust it a little bit, but I'm gonna still let this trigger out. Okay, so I'll put a little more flow on it. I'm just gonna use the other cup so I can do double duty. It don't matter at this point. I already showed you separation. I just got to rinse the cup out or I won't get a true reading. There'll be too much hydrogen in there. You get it right on 3, dead nuts on, well, close enough anyway. Stay above 3, not below 3. Right at 3. Right now we're at 2.33, so we should get it pretty close on this one. And you see, I'm still only taking it out of one side. All we're doing is adjusting the amount of power that we're putting on the water. This is an easier way to do it for video, but we could do it on a program. I should have shown you that one, but it was like at, what did I say, 2.55? I'm pretty good with this machine. Right there, you got it. So if it's 3.0 pH you need, it's 3.0 pH you got, right? Okay, so let's go one further. Let's say you don't want 3.0 pH. Obviously, I could adjust this to be perfect. You know, this is just a quick setting. But we're right there where we're supposed to be, right? Okay, let's go to 5 pH. I just want to show you what I can do. I want to show off a little bit. Oops, wrong one. Yeah, that's the right one. That's the right one. Stopping at 3.19. You gotta admit, that's pretty cool. Just go from 1.55 to 3.9 by just one simple adjustment on a valve. Boom. Right in there where you want to be. We got that much control over this entire process. And I'm just doing it the easy way, real quick way. So now we want to go to 5, right? Let's see what happens. Gotta give it a second. See if I got it close. Just in case I'm going to do a backup. It's still going up. But I don't think it's going to go up enough. We'll see what we get out of this one. So then I got the option of mixing the sides also. But we don't really want to do that in this particular case. But I haven't cut the basics back yet. I just got to get more. We're only at 3.6. So let's see what I get out of this one. There we go. Now we're coming up. Same side, just adjusting the flow. Of course, I don't know where it's going to stop. I might got it running too fast. We're at 5.5. So if we stay right around there somewhere, we're pretty good. There you go. So I took 9.5 pH water on the meter, 8.5 on the meter. We went from 8.5 to 1.5 to 3.10 to 4.75 just by adjusting the flow. And the only thing that flow is adjusted is the amount of electrical conductivity that we're applying. So like I said, I could have shut the machine, went into settings, reduce the amount of power that we're applying to it. But to do it on a video and do it very quickly, the easiest way, turn the valve. So right now, we're applying 29.95 amps and 23.26 volts. And we're running 4 liters a minute. And we got, on the alkaline side, 1.38 liters a minute. On the acidic side, 2.62 liters per minute. So that's exactly what you want. You want the majority of the water on the acidic side at the pH that you want. Throw the other stuff back. When it comes back in, turns back into acidics, everything gets used. So there you are. Plasma Vortex pH pre-tuning for your system. Perfected. And there is no scale limitations. This is just my personal unit for here. How big of a unit do I need or can I have, you know? But it doesn't matter. The largest units that we make to date, nobody's ever ordered one larger, is 200 gallons a minute. That's a big unit. It's made for producing a product by a corporation. But that's the largest units that are running right now. But there's no limitation on them. You need 400 gallons a minute, 600, 1,000 gallons a minute. Doesn't matter. That's a lot of water, but but it doesn't matter is the point. There's no scale limitation. There's no safety problems. There's no risks, no hazards, nothing, period. There's no regulations that you have to follow. Doesn't have to be done in a ventilated space. You can even have a unit built for the outside. I mean, no matter what you need, it can be done. So that's it. Completely adjustable from 11.8 to 2.5 and or beyond if you start using buffers and reducers. But you know, the whole point is to stay away from that stuff anyway. And in what we're talking about here, you don't need anything more. So you got a 100% positive dominant 6.45 ionic pure acidic pure positively charged hydrogen ion filled with dissolved single bubble gases. What more could you want? 561-693-9015. Send me a text first so I know it's not spam. Otherwise you won't get me the answer anyway. Oh, I guess so much spam. Don't you hate that? Where's the laws? Have a good one.